Hey, what's up everybody? In this video tutorial, we're going to be taking a look at how to bring our hexagon cam into our automata and how to fully constrain that at our joints, our joint limits, all that wonderful stuff, and we'll make this work. All right, so the first thing we have to do is if you were following the video tutorials that I've already made for this, what we're going to have to do first is we're going to have to go in there and we're going to have to tear out the follower rods and kind of reset our sliders, all right? So I know when I made the video, I was just basically kind of using those as placeholders to get those into a position where you could see them work. Now we're going to be reorienting those and getting into a position that we can reference so we can apply some measurements. So in order to do this, what we're first going to be doing is coming up here, and if you can't find your joints, just simply go ahead and hit the flyout next to joints. You can come down here and you can see that there are two different sliders. Okay, so I'm going to right click on one slider, I'm going to go ahead and delete that. Right click on our second slider, and I'm going to go ahead and just delete that. All right, so when I do this, I'm going to be able to take each follower rod, grab it, pull it off of the box, okay, and now we're kind of ready to go from here. All right, so the first thing I'm going to do is come down here within your components. You're going to be able to find your two followers. Don't delete them. Instead, just come out here and hit the eyeball and turn the visibility off. I'm doing that because I want to look at the bottom of our actual follower rod. All right, so I'm going to come up here and I'm going to go to joint. I'm going to be picking the dead center of the bottom of the follower rod, orbit this over, and now I'm going to scroll into here, zoom into here, and find the dead center of the top of our guide. When that comes in, if we're not seeing that sliding motion, that means to hit the motion tab, come over here, select slider, and now we can see that that follower rod is sliding in and outside of that square hole. I'm going to do the same thing for our second slider. I'm going to go to joint, come down here, look at the joint origin and pick on it, dead center. And now I'm going to come up here and find the dead center, the top of our guide, and we can see that that's the slider. So I'm going to go ahead and just say okay and accept that. All right, so now these are in a certain location that we can use the reference, and that certain location is just basically the very top surface of our top part of our box. All right, so now I can come down, find our followers within our components, and turn the visibility on. Okay. All right, so for this assignment, if you go out into the Google Drive folder, you're going to be able to see our Automata Resources folder. And one of these you're going to be seeing is the Automata Assembly Information Drawings. And since we're doing Hexagon, please pick on the Hexagon and Snail Cam Information Drawing. So the first drawing that we're going to see, all right, is going to be giving us a lot of critical information. All right, so if we take a look at this, we can see from the top of the box to the dead center of the axle is a distance of 2.25. All right, so that's a very important piece of information. You might want to remember that. Also, I wanted to show you the makeup of our follower and follower rod. So we can see our follower rod is sticking down into our follower. All right, that's using, a 1/4 inch square dowel, and that's going to be going into a 1/4 inch by 1/4 inch hole that's going to be extruded or cut down a distance of 0.25. All right, so just a little bit of math here. All right, we can see that this flat face over here goes down a distance of 0.25, and then we can see that it goes into an arc, okay, which comes around, all right, and that arc has a radius of 0.25. So what I'm trying to tell you is the distance from here to here, okay, would be a distance of 0.375. Okay, so now we have that established. All right, we can see that that square hole is cut or extruded down a distance of 0.25, which means now we can solve, okay, for what this distance is from here down to here, just that small little portion. If we took, okay, 0.375 and we subtracted 0.25, you're going to see that that is a distance of 0.125. All right, so that once again is how far the distance is from here, the very bottom of the hole, to the very bottom of the arc. All right, so just something to kind of remember. All right, and then finally, okay, when we're taking a look at our hexagon, we can see that the distance, okay, across the points is going to be a distance of 1.5. We can also see the distance across the flats is 1.2991. I think it goes on and on forever, but basically, people, it's 1.3. Okay, so distance across the flats and the distance across the corners. Okay, some other information that we need to know. Okay, so with that said, let's jump back here into Fusion. I'm going to be opening up my data panel. I'm going to be coming down and finding my hexagon cam. I'm just going to bring that in. Okay, I'm going to pull this off of the origin, and now I'm going to come up here, use my dials, okay, and I'm going to go ahead and orient this in the correct orientation. Now with the hexagon, we need to verify that the flat portion of our hexagon is going to be pointing up. Everything is going to be based around that as far as numbers. All right, so now that that is in, I'm going to go ahead and say OK. Come here to my data panel. I can go ahead and retract that back. All right, so what I'm going to do is I'm going to be putting the hexagon on the left-hand side of our box underneath our first follower. So I'm going to come up here, go to Joint. I'm going to be flipping our hexagon around, looking at the back of it, and coming here right to the top of the hole, I'm going to be finding this origin point here. Now I'm going to be zooming in here, finding our axle and finding the dead center and having that go right, okay, to that origin point. So the behavior of our joint is obviously telling us this is not rigid. Instead, it's telling us it's a slider. So I'm going to come in here and put on rigid. And now I'm going to go ahead and just take a look, okay, at the front of our view cube. All right, so I'm not done with this joint. So I'm going to come here to position. I'm going to grab this arrow and I'm going to pull this over and get it somewhat close to where the bottom of that follower rod is. So it's going to line directly up with the follower rod. So I can see that that distance is 1.4. All right, so if I look a little bit closer, I think it's a little bit too far to the right. I'm just going to call this 1.35. I think it's pretty darn close. Okay, so I'm going to go ahead and just accept that. All right, so I can now see, okay, that my hexagon cam is attached to my axle and is directly below my left follower. All right, so now what we have to do is we have to come in and bring our follower rod and our follower down where the actual follower rests right on top of the cam. All right, in order to do that, I'm going to be coming over, all right, and finding the slider. So if you haven't figured this out, when you just simply hover over a slider joint, okay, you're going to be seeing how it's going to change the color of that to like a darker blue on the icon that's attached to the follower. So we can clearly see that's a darker blue. I'm going to right click, and this time I'm going to be picking on Edit Joint. So when I go into Edit Joint, I'm going to grab the arrow and I'm going to pull this down. We can see that that's going into a negative direction. All right, if you remember, when looking back here at our reference drawing, okay, from the top of the box, okay, to the dead center of the axle, that is a distance of 2.25. So I'm going to be jumping in here to Fusion, and I'm going to say I want this to come down negative 2.25. And you're going to see that's the dead center of the axle. The thing is, we also have to add in that small little piece of material, okay, at the bottom of our follower. That's between the bottom of the square hole and the actual arc. So we have to add in the 0.125. And then we have to also add in what the distance is going to be from the dead center of our hole on our cam, okay, to the top of the flat of the hexagon. So if we jump back into our reference drawing here, okay, we can see that that is a distance basically of like 1.3. All right, so if I calculate this out, 1.3 divided by 2 means that's approximately a distance of 0.65. It's pretty close. So back in Fusion, I need to add that 0.65, so that's going to be sitting right on top of the flat of that hexagon cam. So I'm going to go ahead and just say OK on this. All right, so I can see the follower is resting right there on top of the hexagon cam. You don't have to do this, but what I'm going to do is come over here. I'm actually going to be turning off the visibility of our side so I can then use my view cube to look at it from the right-hand side, and we can see that that follower is resting right on top of the hexagon cam. All right, so I'm going to turn that side back on. Okay, and now we can start adjusting our joint limits. Okay, so in order to do this, what I'm going to have to do is come up here and find the right slider. Okay, so I can see that this is the darker color blue here on this slider. So I'm going to right click and come down and pick on Edit Joint Limits. Okay, so with the hexagon, where it's at is kind of its lowest point. So I'm just going to go ahead and just say my rest is equal to 0. Okay, now what we have to do is a little bit of math here. So going back into our drawing, we can basically see in order to find the difference between the distance across the points and the distance across the flats, we would be taking 1.5 and we'd be subtracting 1.3 from it. Okay, so 1.5 minus 1.3 leaves us a distance of 0.2. All right, so on the hexagon, we're going to be saying the maximum that we're going to go with this is going to be a distance of 0.2. All right, so I'm going to go ahead and say OK. All right, and now what we're going to do in order to make sure it works is we're going to come up here, go to Assemble, come down, and we're going to say Enable All Contact. All right, and now anything that's going to be running into each other is going to be able to detect that that's there. All right, and there's going to be sort of a relationship. All right, so I'm going to put this into our isometric view on the view cube, and I'm just going to come in here and I am going to grab a hold of the handle and we're going to see if hexagon behaves the way that it should, and we can see it does. All right, so in order to get this back into our home view, if you come up here to your revolute joint, you can right click and say I want to go to the home position, and now it's been reset back into its original position that it was. All right, so there you go. That's how we bring the hexagon cam in, and that's how we fully constrain that, getting our joint in the right location. We edit the joint and then go and edit the joint limits, and we're also applying our contact set, right, to make sure that this works. So there you go.